Okay, so thank you for letting me present this. My name is Damian Hatwell. I look after the technical sales and support team at Bridge Technologies. We are a Norwegian-based company, but I'm originally from Australia. Been around the industry for a while, so got some experience. So we'll talk about a little bit of that today. So what do we talk about today? So the main focus here is IP production. So IP production is moving ahead and now is actually being used in some of the biggest shows and events in the world. But what are the challenges moving to IP and how can we mitigate this? And what have we learnt along the way? So we'll share some of our stories and some of our experiences and open it up to questions for you guys in the end. So who are we? We are Bridge Technologies. We were founded in 2004. We're a privately owned company in Oslo. We're about 35. I think we're growing now, so almost just under 40 employees. And we're very engineering centric. We've been around for 20 years, so we're well established in the industry. So where have we been in terms of IP? So the move from SDI to IP has been a very slow one. It's been happening over the last decade or so. And the first step for this was 2022-6. This was fairly simple, which is basically taking the SDI information, the whole every bit, and just putting it into an IP packet. This was based on multicast distribution, and that had been successfully used in IPTV and distribution headends now for a while. And they faced a lot of the challenges that we'll be talking about here, moving from previous sort of ASI-based distribution into an IP-based distribution. In 2017, 2110 was first introduced, and we started gaining traction about 2019. And this was further helped by the need to move more remote in 2019 and 2020. And as of now, we're seeing 2110 being some of the biggest events in the world and gaining both maturity and support in the industry. So what's our story? So in late 2019, we introduced our first product, which handled IP.
Hi.
Hi.
It's the...
So,
It's an exam. Do your best to I did not pass. I did not pass. You didn't pass?
Thank you. Yeah, so in 2019, we introduced our first product, the BB430, which focuses on uncompressed IP networks. So historically, we've been based on previous IP and distribution technologies, so ASI, QAM, satellite, with a strong focus on IP and IPTV and OTT. So in March 2020, all of our staff was told to work from home, along with every other country. So the production landscape really changed overnight. Suddenly, IP connectivity was really critical to keep things going, and we had a unique opportunity to be a part of this. So what we did internally, our marketing, which we generally use at trade shows and going to visit customers, we couldn't do anymore. So we actually internally built our own IP studio. So we started gaining experience on our own turf, using our own equipment, and then building an IP studio, which we then used to do remote presentations and all our social marketing. We actually came up with a YouTube show. So we've had a YouTube talk show about the industry during the pandemic. So that really helped us gain understanding of how IP was used and how our customers could use IP. So what is 2110? 2110 is a suite of standards. There's a lot of different parts of this listed on the screen. So Dash 10 talks about how we put together 2110 streams. When you hear someone talking about Dash 20, that's the video part of 2110. Dash 21 is the traffic shaping and delivering and how the timing is organized. Dash 22 is compressed video, and as an example, JPEG XS. Dash 30 is PCM digital audio or AES67 audio. Dash 31 is AES3 audio. And Dash 40 is transport events, empty ancillary data or metadata. So the first document describes how this all fits together, and then how we use this to send a stream over IP using RTP, PTP, for example. So what does that look like? So each 2110 stream is an essence. It's separated into its own multicast, which allows you to control where each essence or each stream goes. The benefit here is, say, for example, an audio control room. We don't need to send the video now to an audio control room. We can just send the audio multicast there. So it allows a lot more flexibility and a lot more actual data saving because we don't have to encode every single bit in the SDI packet. So even over 2022-6, there is a bit rate saving by moving to 2110 because we can separate the essences into the video, audio, and metadata and only send what is needed. So why would you move to IP? Well, there's lots of benefits. There we go. So there's lots of benefits to moving to IP. So as an example, scalability. It's an easier expansion compared to traditional SDI. SDI, we're no longer needed point-to-point SDI cables, but we can use IP networking to easily transport streams and scale quicker. Flexibility. Seamless integration, new remote and data center workflows. So IP connectivity brings the ability to connect from anywhere and the ability to shift workflows to remote equipment. Granularity. We can add individual streams or essences. So if we need to add an audio, we can add another multicast on top. If we don't need metadata, we can drop that stream. Cost effectiveness, cable infrastructure. IP reuses a lot of the technology that's already in the data IT industry. So we can get some cost savings there by using the same equipment. And future-proofing. The ability to scale up with IT-based and IP-based workflows is a lot more versus a traditional sort of SDI workflow. So the benefits of being an IP-based workflow: higher density equipment. So now that we're using software and sort of IT-based infrastructure, software solutions allows more complexity to be condensed into less equipment and also provides more future upgradability. We also have portability. Equipment doesn't need to live in the MCR or the OB van anymore and can move into data centers or racks. So this creates less noise, less heat, complexity in places that can benefit. So a good example of this is an OB van where equipment now can be moved into a rack and allow the desks to be a little bit more clean. So multicast routing is one of the big benefits of IP, and this allows us to route streams to multiple destinations. So instead of having a point-to-point SDI connection or a big SDI router matrix, multicast routing can allow one stream to be sent to multiple different receivers or with just the network. We also get IP-based redundancy solutions, which I'll go into a little bit more detail, but 2022-7, sometimes called hitless protection, allows dual path redundancy for our signals. We can also add network tools on top of that, like OSPF or BGP, and allow network engineers to build additional layers of redundancy on top of the network. And we also have IP-based control systems. So NMOS, which is another thing I'll go talk a little bit about, which allows multi-vendor compatibility in our control systems. So 2022-7 and redundancy. I'm not sure if everyone knows about this, but this is a way to send the same stream over two independent paths. In a network, we generally call this amber or blue or red and blue. And what we do is we send the same stream over the two different networks. Then when a receiver receives it, it gets the same stream on two networks. The benefit here in using IP is that if one packet goes missing on one network, we can then realign the streams internally. So you can think of it like an XOR of the two streams. So if one packet goes missing, we can grab that from the other link. If it goes missing on the other link, we can grab it from the first one. There's no concept of primary, secondary here because both paths are considered equal. What that allows is to give us a very robust solution for sending streams, and these are big streams, over an IP network. I also mentioned NMOS, so I just wanted to quickly give a quick overview of what that is. So NMOS is the metadata transfer of how we talk about 2110 streams in the network. So this would primarily be used by your control systems to find out about each other and how to exchange metadata about the streams. We generally have a NMOS registry which sits on a network. Every 2110 device registers here. describes what it has, puts metadata there, and then we have an NMOS controller, which then can send, say, to the receiver, hey, look at this NMOS node, can you receive it from here? The NMOS node, the destination, will then also just automatically receive that. So the NMOS node will be notified and fetch that stream from the network. So where can we use 2110? So there's lots of different places in the IP sort of production workflow where we can use 2110. So the first example of this is an IP-based OB-VAN or PCR/studio. Here we have IP cameras or even SDI cameras that are coming into a 2110 gateway, going into a network, amber blue, and then being produced. So here we can do everything we do in an OB-VAN just with IP. We can do the switching, we can do the mixing, the graphics, color shading, and then that's all done on IP. So this is just a couple of our customer examples that we have using IP vans. These OB vans are being converted to IP-based 2110, and they're using IP-based tool sets in the van themselves. Also added a screenshot of our IP-based studio. So this is the studio we created during pandemic, and we were doing all of our camera shading and everything on using our BB440. I mentioned before about one of the benefits of IP is being able to do remote production. So here, what we can do is actually just send all the IP signals, all the camera signals from an acquisition or OB van into a remote production facility. Here we can then, with those IP streams, do everything you would have done locally on the OB van in a remote production. A lot of people are doing this for cost saving measures. If you use remote production, you can reuse a remote production center for multiple different events or studios, and allows more flexibility for your equipment. So this is just an example of a large football tournament. This is actually remote camera shading. So the operators here were looking at remote cameras and doing the shading here in the remote production facility. Another example of our studio, we set up our own little MCR so we can monitor all of our streams internally in our MCR. And we've got a customer example as well. And the last example is contribution, sort of distribution playout. So this is where you're receiving your last feed. You've got a feed, it's all 2110. This is where you can check it before it goes out to either distributors or being re-encoded for other distribution. So here we can check the final playout, making sure the graphics look good, making sure the ad insertion looks good, making sure the ad insertion, SCSI markers, subtitles, everything is there before it goes off to distribution. So that's all good stuff. What can be some of the challenges here? So some of the challenges we can have migrating to IP. Complexity. This requires specialized knowledge and training, which hasn't existed before in the production environment. So training, upskilling teams in IP. And I remember one of the German broadcasters saying specifically this in one of their talks, is that this was one of the challenges they faced because upskilling the teams to new IP standards was a big task. One of the benefits here is we have been using IP multicasting in the broadcast industry for a while. It's been used in the distribution, so the likes of Deutsche Telekom and such. They've been using this sort of standard for a while, so the knowledge is there. There's also interoperability, different vendors working together. There is compliance, so use of standard 2110 and NMOS. And there has been interoperability, sort of plug fests together. So a lot of the old vendors are working together. I would say that probably 2019, 2020, there was a bit more incompatibilities, but now in 2024, everything generally works together. So the other challenge is monitoring. We're used to having cables, an SDI cable, you knew where exactly the signal goes. Once we go into an IP flow, you don't exactly know where the flow goes. So monitoring and visibility on the IP flows is very required. And then network infrastructure. We're talking big bandwidth. We're talking network designs that require high redundancy and QoS. A 4K feed can be up over 10 gigabits. So multiple 4K feeds will easily go over 40, 50, 60 gigabits. So these are big networks which we're designing. One of the other challenges is now that we inherently separate the video and audio, we now have to be a little bit conscious of synchronization between the different feeds. If we separate the video to go through a switch, a graphics engine, the audio goes through an audio mixer, these have different processing times. We need to make sure we can align these in the presentation layer. So that's something we need to be aware of. So as mentioned before, high capacity IP networks. Some of these switches are very large. We're talking 100 gig leafs, we're 400 gig spine switches. And while the network switches are similarly based as IT industry, video broadcast does things slightly different. So there are specialized video switches or switches which can be put into sort of video mode that suit this application. We've also got IT and network security. This is the same challenge we're facing in the IT world. The difference here is that we have a broadcast data network. So while the data network is generally closed and closed to multicasts only, we still need to be worried about all the equipment we're putting onto our network. So there is a large benefit here with the IT world and where security best practices can be applied. As I mentioned before, once coming from an SDI world, you need to understand where your streams are going. And that's one of the challenges with monitoring IP. How do you check that your redundancy is working? How do you check if you're getting any packet drops on one link or not the other? In the IPL world, if you lose a packet, you lose a pixel. And that's obvious then in the ending picture. We have PTP and RTP to help us with this. And we also have 2110-21 and 2110-25 standards to help us monitor these parameters. So what sort of thing will we look at when we look at monitoring? Well, we want to look at the packet flow. We want to see if packets are getting to the errors, ensure quality. We want to check that the streams comply with 2110 because we're dealing with very tight buffering models in IP. We need to make sure that the sender is actually applying standard. We need to have scalability. How do we know we're not going over the link rate? How do we know we're not pushing the switch too hard or going over the bandwidth limits? Are we getting packet loss? Are we getting IP jitter? Is there any latency in the switch or any latency that the switches are introduced? How do we visualize this? How do we look at this? And what do we need from a NOC? So while production's used to having an MCR, you may now need a NOC as well to look at the IT side of the 2110s. So luckily, being BridgeTech and being a monitoring company, we have some tools for this. So we do look at the timing values, we do look at packet loss, and we have those things available. So when all things considered, what do we get from 2110? What are the real benefits and what's the new workflows that can be introduced? So one of the biggest ones is web-based tools. So in previous SDI-based, you generally used to having a cable, whereas now the equipment sits in the data center and everything is available remotely. This means people can pick up a browser anywhere and look at what's happening in the studio. So we have different tools to visualize what's happening and then remotely see the studio or the OB band or the streams. We've had examples of customers running from multiple different countries looking at the source streams for sporting events from other countries and looking at the live feeds. We also get APIs and automation. So now everything is IP-based, everything is metadata-based. We can create more advanced APIs and automations to create new workflows to quickly spin up and dynamic production facilities. We can press a button and create a new workflow in a control system. We also have compression and flexibility. So one of the good things about 2110 is we can extend this. So JPEG XS allows you to send visually lossless feeds over lower bandwidth connections. And this is some of the stuff that's already being put into use in big football events. And other IP tools. So one of the examples we had is we've created a clean switcher camera control, all based on web-based video previews. We also are working with IP-based speakers, so for audio monitoring. Now that we have everything in IP, we don't necessarily need a audio listening device in the rack. We can use IP-based speakers to route audio. And instead of using high quality screens, we can use prosumer or high-end consumer devices. So we also have iPad mounting kits. So we saw it before in the OB vans. Customers are now using iPads. They provide a high quality screen, touch interfaces for both monitoring devices or control systems. So it allows you to create and rethink new workflows. So where are we going? So as I mentioned, IP production is moving ahead and being used in some of the biggest events in the world. Future sporting events are investigating being pure IP production and how that would look. Studios and broadcasting, especially greenfields, are starting to do new IP studios from the ground up, IP-based AV vans. We've even heard of some cases where post-production houses, in order to check the quality of the output in the post-production, they're using 2110 to then route streams to viewing centers or preview rooms. So creative engineers, the insight and understanding into production metrics in real time, with no latency, so that they can monitor this. And advanced tools to navigate a new way of working to complete tasks fixed, remote, or distributed. So if there is any further information you'd like, the Bridge Technologies website is there for us. We have some case studies there. We have a YouTube channel with lots of information there. We're on LinkedIn. And then for any sort of inquiries in Germany, Michelina and Manuel are ready to help you. So I'll say thank you for now and open it up to questions.